Thank you for having me. Today, the subject is data quality management from three perspectives: the good perspective, the bad perspective, and the messy perspective. But before I jump to this subject, a little bit about myself. I'm Jan Meskens, and I'm a Belgium-based data and AI strategy consultant. In this role, I convince organizations to use all technology that I've seen here on this conference to solve real business problems. I do this in my own company, CVAX, and I will share my slides, of course, through the conference platform, but also on LinkedIn together with an article. So feel free to add me during this talk. So back to the subject of today, data quality management, the good, the bad, and the messy. While the logical order is to start with the good and grow towards the messy, I will do it the other way today. I will start with the bad. The bad are all issues that we experience with bad quality data. All things that can go wrong. Then we shift to the messy. We're going to look under the hood. All messy stuff that we do with data that causes those issues. And then we go towards the good. How can we solve those issues? Okay, let's start with the bad. At least I experience almost daily data quality issues in projects with my customers, but also as a customer myself of many services. I will just give a few examples to give you an idea about what are data quality issues. One example is from a customer perspective. Suppose you are a customer and you are ordering something and it's never been delivered. That might be because there's a data quality issue, because your address is not correctly stored by your supplier. Then you can ask for more information in a support chatbot, but if the data is not correct, the chatbot cannot find your order. That's from a customer perspective. Then you have an employee's perspective. What if you get a wrong salary at the end of the month? Because the timesheet application that calculates everything does not contain the right data. If you don't have the right times that you worked, it's difficult to calculate the right salary. And then you have many other examples. If you analyze something, if you make a decision based on a KPI and your data contains issues, you will not draw the right conclusions. So those are some examples, some fragmented examples in different roles where data quality can make things go wrong. But it's not always in this isolation that things happen. In the beginning, data quality issue might influence a few stakeholders. I compare it with a small fire, and you can still manage a small fire. But if you don't manage it, it starts to grow, and it grows further and further, and it can result into chaos. That many processes in your organization go wrong because your data quality or your data has not the right quality. So it's very important to manage your data quality. While I hope that you're now convinced that data quality can make things worse and can influence your daily business, we will look to the messy. What is happening under the hood that you have those data quality issues? Let's go back to the examples that I gave. 4 examples of data quality issues. To understand the messy, we now need to look what happens with our data before it's being exposed to those persons here. And that's looking to the life cycle of your data. Everything you do before it enters the final consumption system. And that's an easy answer. What happens with your data before you see it on the screen? It's an easy question, sorry, but the answer is more complicated. For some organizations and for many organizations, they are sometimes not able to answer it. They have a data mess. They just connect things with each other, but they don't have any clue how data flows from A to Z. And what is such a data mess? It can contain out of many tools, and each tool is implemented very well, but you don't have a complete picture how everything connects. So for me, the first step in understanding the messy stuff that happens with data is to decipher the data mess. Let's decipher what happens with your data from A to Z. And this is the data life cycle. And of course, the first thing in the data lifecycle is creating your data. Creating your data is being done in processes by users by means of software tools. This is a process where you have users that are executing tasks in these processes. These can be internal employees, it can be external stakeholders, it can be your customers. They are working in a process. And they are working in a process with a tool, with an ERP system, a CRM system, a mobile application, or with machinery equipped with IoT sensors. And all those software tools are creating data. And from then on, we talk about data sources. Your data is being created, is being updated. And that's the beginning of a journey of our data. Data will leave the source and will be pushed to other corners in the organization. And therefore, we often use data pipelines. We extract data, we transform it, we integrate it with other data, we reform it, and you will find data in another application, in another form. And that's the data which is ready to consume, and there we connect our consuming applications with. We connect our reports, our AI tools, and our other tools to do valuable stuff. And that's a very easy or a very straightforward view on a data lifecycle. Maybe two things to add here. The left side is what we frequently call upstream, and the right side is what we call downstream. And data flows from upstream to downstream. Now, in the context of this talk, I want to add two more things to this schedule. The messy stuff, all things that we do before we use the data, and the bad, where we experience the issues. So on the right side, we see the issues, and on the left side, we do things with data causing those issues. Now I will step through this messy stuff. I will start on the right side, which types of errors that we can see over there, and gradually we will go to the left to find out causes of those errors. So first, data consumption issues. We have our data, we connect with it, and we create, for example, a dashboard. But there are some issues. If you start looking into this, this is well described by dimensions of data quality. Some talk about 10 dimensions of data quality, 8, 3. I usually talk about 5 dimensions of data quality. 5 types of errors your data can have related to data quality. You have accuracy, validity, and so on. I will not go through every dimension in detail, but a few are interesting to tell a bit more about. First of all, accuracy. Suppose in reality your data is a triangle, but you store it as a rectangle. Then you have a problem. Remember the customer that never receives its package. You store the wrong address for this customer, so he will never receive its package. Very hard to resolve. Here you have consistency. You have the same data in multiple systems, but the data looks different. Which data is leading? Which system is the master of your data? And then something, timeliness. I heard talks about orchestrating everything that happens with data in your organization. And that's very crucial, because if you deliver your data too late, a subsequent process will start using outdated data to take decisions and so on. So, all types of problems that can go wrong with data. But what's the cause? The first cause is issues with your pipelines. Here you have your sources transformed in new data, and that's being done by a data pipeline. Some people forget, I expect not in this room, but some people forget that this is software. And you need to manage this as software. You need to test it. You need to see that everything that goes from source to destination goes in the right way. But you have many departments, not IT skilled, not very mature, building all kinds of things, and this can cause issues. A very simple example. Suppose you have a pipeline that transforms data from the input to an output. You have some input data and you transform it to output data. Suppose you have a triangle and a rectangle, you should transform it into a rectangle, or you transform it in a rectangle, but that's wrong. You expect a house. So here you have a bug in your pipeline. You have pipeline bugs. And that happens frequently. And then you have the source. At the input side, the beginning of the data life cycle, there it can go wrong as well. You have inputting the data in a system. You have users that input wrong data because maybe they don't know how to input it. Maybe they don't have a manual on how to input it. And you also have software issues. All software being used here, if you enter the right data, they can contain a bug and store the wrong data for further usage. So at the beginning, it can already go wrong. So we have this complete life cycle. In this complete life cycle, we have different types of problems. Data at the input side can contain issues. You can have software issues, issues with the pipelines, and at the end, you see this as consumption issues. So I hope you now understand what's the messy stuff that happens with data before you start to consume it. Because this brings us to the good. We want to do better. We want to improve this way of working and gradually improve our data quality. Let's go back to our schema, where data flows from upstream to downstream. And there's one important pattern on how to improve your data quality. And that's the so-called shift left pattern. On the right, you have downstream, where you experience your data quality issues, but the causes are more to the left. So you need to shift your view to the left to resolve your data quality issues. That sounds easy, but it's not that easy to do. Therefore, I created 3 golden rules to implement a shift left in an organization. 3 golden rules. The first one, fix the root cause. Don't fix it intermediately. Fix the root cause of your problem. Secondly, fix it fast. Don't wait too long, because if it starts to grow, you might not be able to control it and clean up your mess. I will go through these rules. First, fix the root cause. If we go back to our schedule, from upstream to downstream, the different types of issues you can have, issues at the input side, at the software side, at your pipelines, and finally in consuming the data. You need to fix the root cause. What is not fixing the root cause? This. Tweaking it in a report. At the end you see, data is not correct, let's tweak the report so that it looks correct. That's not fixing the root cause. This is also not fixing the root cause. Let's fix it in an ETL. Our ETL can clean the data and then later on we can use it. That's also not fixing the root cause. What is fixing the root cause? This. Let's fix it at the beginning. Look where it goes wrong for the first time and fix here your issues. If you do it shift left, you should look to the origin of your data quality issues. Now, you know you need to fix the root cause, but I also say fix it fast. And why fixing it fast? That's very similar to solving software bugs. The earlier you fix a software bug, the more easy it is to solve it. If you have the negative impact that a software issue can, the negative impact that a data quality issue can have and the time it takes before fixing, you will see again the pattern of the wheel of chaos. In the beginning, you have one user who is impacted by a data quality issue. After a while, they start to propagate further and further. You have multiple users, multiple systems which are infected. A bit later, your wheel starts to grow, and at the end, you even might have media exposure, and not that kind of exposure that you want. So what I say, try to fix it here. Don't wait before it starts to escalate. And then the third rule, clean up your mess. To understand this, let's visualize how many bad data is being created by a certain data quality issue. If you have the time on the x-axis and the bad data that is being created by an issue, you can see it like this. In the beginning, new bad data keeps appearing in your system because you have an issue. At a certain point, you fix the root cause. Fixing the root cause means no new data will enter the system. But then the old data remains bad. So the things that already entered the system are still bad. So my advice is also invest in cleaning this old data. Cleaning your historical data, because someday you might need it in the future. So this could have been the end of my talk. Implement 3 rules as data quality management strategy and it will go better. But unfortunately, in reality, things are more complicated than I just showed. Actually, fighting your data quality issue is, for me, fighting a 7-headed beast. A 7-headed monster where the good needs to fight against the bad and the messy. And what's specific for a 7-headed monster, if you cut off 1 head, you get 3 new heads. I once started to draw it with 10 heads cut off, but that's not possible. So, before I explain how to beat this monster, let's try to understand this monster. Why is it so hard to fight data quality issues? And that's because the 3 golden rules to shift left are difficult to apply. There are some things that make it hard to apply those 3 rules. First, let's go to fixing the root cause. What makes it hard to fix the root cause? Let's retake our schema. From left to right, from upstream to downstream. I already said some things about the technological part. Things that we do with technology, pipelines, bugs, software issues, and so on. But I didn't say anything about the people and their responsibilities into this process. Let's take a look. In the beginning, you usually have business team, responsible to input data. Then you have an IT team, responsible to manage your IT infrastructure. Then you have data or streaming teams that create pipelines. And at the end, again, you have business teams. So multiple stakeholders are working in this life cycle. But in reality, it's way more complicated. It are not just a few teams. Everyone is working in a sub-team. They are working in silos. You have typically a siloed organization where every silo has its own priorities, its own thing to work on. And what's the hardest part in data quality management, that the bad, the pain is being felt at the right side, but it originates from the left side. So people responsible for the data pains don't necessarily feel the pain. And people that feel the pain are not the ones that necessarily create the data. And if you then say, let's solve the root cause, yeah, you need to talk with each other. And there are the silos. And that makes it very hard. And then you have the other 2 rules, fixing it fast and cleaning up the mess. If you ever worked in software and tried to solve bugs, you know, fixing fast, putting it on a backlog and so on, that's all a difficulty. But if you see it in the context of data quality management, a data quality issue is usually detected very late, which means there is already some damage going on. And then at a certain point, if you fix the root cause, no one has an idea how to clean what did go wrong. Who's responsible for that? How do we need to clean it? Is our software able to clean it? So those kind of things, those kind of data management things are usually not implemented. So 3 golden rules that I sold to you seem to be difficult to apply. And difficult to apply, so difficult that I compare it to a data quality monster, a 7-headed data quality monster. But I want to do better. I want to beat the monster. So I'm looking for a magical formula. A magical formula where we can beat the monster. And certainly not start to cut off heads, because then you can never win. So let's search for the magic. And the magic for me is in data quality management. Data quality management is actually looking for a strategy on how to manage your data quality. And with a strategy, I mean, look for how you can sensibilize the people in working with data for data quality. How to implement the right processes on doing better with data quality. And how to use the right tools. And the difficulty in applying a data quality management strategy is in finding the balance between those 3. And it's very hard, if you have one organization that is able to manage its data quality very well, to copy-paste it to another organization. It's, one hand, the type of business those organizations are doing, and on the other hand, also, the maturity that those organizations have, the data maturity in how they manage their data. I will now give you 3 examples of 3 organizations, each on a different level of maturity. You have the maturity level, you have your organization, you start here, very low data maturity, you start to manage your data quality, you can grow and grow. So let's start with an organization at a very low data maturity on how to manage your data quality. The first advice that I give to customers of this type is make someone responsible for your data quality. Appoint a data quality manager. And what's the first role of a data quality manager? Try to break silos. Try to bring people together across teams. Try to talk about and sensibilize why we need to solve a certain issue. Try to identify root causes. This is not the most popular function in an organization, but if you have a good one, you can really do and take big steps. But a person alone is not enough. You also need to implement a process. And what this person is doing here, I compare it usually to classical backlog management. Implement a kind of data quality backlog management. Inventorize all issues that you find, do an impact analysis, and order it from high to low impact. Then you get a view on what goes wrong with data and what are all things that we need to fix. Once you have this backlog, you can try to find solutions. Trying to find solutions means dispatching the work to another team in this case. For example, if something goes wrong with your data pipelines, you dispatch it to a data team. If something goes wrong with your software, you dispatch it to an IT team. If at the beginning people enter the wrong data, you dispatch it to a business team to do better, to look how can we improve the way of working. So these are processes that you need to implement. And then finally, of course, you can help this with technology. You can implement data quality sifts. I compare it with a sift or a filter that can filter good from bad data. You can, in this life cycle, at multiple stages, implement a sift. For example, at all those stages, you have sifts that will identify, due to a business rule, if data quality is bad or good. And you can grasp all this metadata and you create a data quality monitoring dashboard. And that's very helpful for your data quality manager because he already has an idea what goes wrong, what works, what doesn't work. But this is a reactive approach. You're going to look for bad data when it's already in your system. But you can also push this to the front. You can use this in a kind of master data management system, where you will use proactive rules, validation rules that will validate your data before it's being entered in a system. This is something I strongly believe in, and the clue here is in creating the right metadata to manage your data. So this was a low maturity organization, but you've seen, due to the data quality manager and all things that he did set up, the organization starts to work better. We start to identify data quality issues, we start to work together across silos, and the maturity grows. So we end up with an organization somewhere in the middle, with a higher data maturity already. What's the next step in growing? The next step is in growing data maturity and in managing better your data quality, is in implementing business data accountability. Instead of having one set of data quality KPIs which are managed by one person, you start to shift responsibility to different business people in the organization. Just a few examples. A CFO might be the accountable person for all financial data in your organization. It's not an IT accountability. It's the accountability of someone in the business. The same for an HR lead. He may be responsible and accountable for all HR data about your employees, and so on. And the data quality manager can then grow in a kind of CDO role, a more strategic role in facilitating this. Once you have this, you can start to grow further, and you can become a very high mature organization. Here I will just show it very quick because it can be separate talk, but a very high mature organization can start to work in a more decentralized way, in a domain-driven way, where you have separate domains in an organization, and in such a domain, people are responsible from the creation of the data up till the delivery of a data product. So they deliver products where you have your data packaged in a usable way, together with metadata, how good is this data, and they can immediately intervene because they're also responsible to create the data. Many organizations start with this idea in mind if they are at a very low data maturity, but it's very hard to achieve this state if you don't take the intermediate steps. So this is something you might want to achieve. So by implementing this, we create a tool, a data quality management tool, to at least shrink the monster. The monster is not so big anymore. And if we start better to work together and to implement this further and further, it can shrink and maybe even disappear. And that's the goal of data quality management. So this brings me to my conclusions of data quality management: the good, the bad, and the messy. What should I advise? As a first step, I would advise decipher your data mess. Organizations have many tools, many ways in how data is being connected and pushed through the organization. Decipher it, make a clear plan so that you know what is the typical flow of data in this organization. Secondly, look broader than only technology. Look also to the people, their role in the data lifecycle. Look to the processes who create this data. And also focus on technology where it can go wrong. Find the balance here. And you find this balance to implement a data quality management strategy. Look for the right strategy for your organization that will implement some kind of a shift-left pattern. A shift-left pattern so that you can easily solve your issues on the left so that you don't have impact on the right. This was my talk. I'm open for questions now or afterwards. Thank you.
Questions?
Hi. Great talk, by the way. Thank you.
Thank you.
The first approach for the data quality implementation with the data quality manager, there was a part that talked about the sifts, and you said that it was a good idea for the data quality manager to implement these sifts. But at the same time, this is for a small organization. So my question is, what's the profile of a data quality manager that allows him, for example, to do his job, do organizational analysis, the processes, and also implement this apparently very technical thing?
Yeah, very good question. Maybe I didn't phrase it very correctly because usually the data quality manager will not implement this himself. So data quality manager is more someone who is very good in building bridges in an organization. He has very good the people and the project management skills, but is just technically enough to coach a team to implement this. So once you go to the technological side, you need people or tools to implement this. So we need to work together, but the core skill of a data quality manager is building bridges and breaking silos and actually making a first project or program about data quality. Is that an answer to your? Yeah, very good question. Thank you. Some other questions? Yes.
Yeah, so thanks for your talk. So what I'm wondering is if you have any recommendations in the situation. Well, you had this nice visualization where you're solving a problem by cutting off branches instead of solving the root cause. And say you have accumulated this over years, and how can you make it clear that this was not the good way to do it, and you're still suffering the consequences. I mean, how do you get priority to solving the root cause after all this time?
Yeah, that's not something that I mentioned in why is it difficult to apply the rules. It's actually why is it difficult to fix it fast, because you have some history. There was an issue for years, and now we say we need to fix it. Now there's something that can help you. That's something that already everyone knows in the organization. Typically, you say we need to touch this and fix this. Oh no, don't touch it. We have it for years. No, we don't know how to solve it. We don't have time for this, and so on. Yes, start to explain what will go better if you solve it. And if you solve it, do some investigation where it goes wrong. Then you can put a number on it. It will cost us so many days, so many budget to fix this issue, and you get this in return. It's a business case that you need to create. And that's the role of your data quality manager, to bring those business cases, and that was on this slide, on the right board. You have your backlog, but actually here you have an impact, a business case, and that should be enough to put it on the boards of separate teams to solve it. But do you need budget to improve your data quality? Yes, you need budget, and you also need the intent of your management, to put them behind this, because otherwise you can list it up, you can have a backlog, nice, or data quality is bad, but we don't do anything with it. Just don't do it. Then you spend money for no result. I don't know if it's an answer to your question. Yeah. Okay, thank you.
This is a little bit more of a statement than a question, but we work really closely with chief data officers to help them with their data, and we reveal a lot of these problems. And what we find is that a lot of the chief data officers really don't have a lot of power in the organization. Mm-hmm. They don't really own the data. And so they really, they don't have the budget, they don't have the means, they can point out questions or problems like all day long, but nothing happens. And maybe worse is, as AI is becoming more prevalent and important for organizations, sometimes the organization tries to make the AI lead also responsible for data. Mm-hmm. And obviously there's a lot of conflict there. AI is, you want rapid, movement with data. You're not necessarily as concerned about quality or protecting data. So it's just, as I started, it's more of a statement, but it's an incredible problem.
It's a very interesting statement. And actually what you're saying, I can compare it a bit with what you see in the cybersecurity world. You might have a lead of a cybersecurity team with less power in the organization until you have an incident. And then it's okay, we have budget, we will do everything to no longer have data security issues or cybersecurity issues. The same holds for your data. Why is a chief data officer not the right power? Because the people around him think, everything works. Why do we need to improve things and so on? But it's just, are you going to wait until it breaks and you have a really big issue? Or do you want to employ a more proactive mindset? And to have this, that's thinking in strategy terms. Thinking about what if we invest a bit budget to improve our data quality now, instead of waiting and then we need to move everything to fix it. So that's a bit of selling, profiling your chief data officer. I saw yesterday a talk about the glue work, that are those kind of things. Profiling yourself and what can you bring in the organization. But it's a very good statement. It's also reality. Thank you for that.
That was a great talk, thank you. So I have a question about the SIFT and the validation. So is a SIFT just like some examples of like some checks, and the validation is like the generalized rule for it? And why was the validation not done in the first place in most of the systems?
Very good question. That's because at this site, implementing your SIFTs here is easier than here. Because if you want to implement a SIFT at the first stages, you need to have some integration with your software systems over there. Or you need to have a separate tools where many people need to check. This works best if you have massive amount of data that you enter in your system. And then you can create rules like this. On the right-hand side, this, in the most easy form, can be a SQL statement, for example, where you're going to check in a very easy way, is this field empty or not? And you can see, is there a link with another system, and so on. So you can implement this. You have tools for that. I think the most known open source tool is Soda to implement that. It's more like testing your data, but on the left-hand side here you see it, you have a master data management approach that's connecting with your processes to enter it. And I like your suggesting starting with this would be the ideal world. But in many organizations, they don't want to start with this until they see how worse it is here. So again, this is cheap to do in the beginning, cheaper, and then you can grow towards this. But if you have enough power as a CDO, start with this at the first. Totally right.
Thanks for the talk. Just short question. Do you have some tips or trick to have this culture also on the producer of data sites? Because often, yeah, at the end we have problem, but as you mentioned, we can fix them in ETL. So let's fix them there and never fix them at source. So how do you convince the people that fixing the root cause is actually advantageous to everyone? Because I'm not able to do it.
That's again, a very good question, and it seems that you ever experienced this. And I think the reason why I start working in this is the frustration that I feel in a data team. Because we need to deal with all the shit from the systems that are coming in, sorry for the words. And it's just a question, hey, we have something wrong in the report, fix it, data team. So they are all pointing to you. Yeah, you have some strategies like we don't do it anymore, but that's not a popular strategy because here you see your shit. What helps for me is making it insightful, creating a monitoring dashboard. Really make it clear from which software system or which entity, which data quality problem appears most. And you can even start to calculate how much money does it cost that this appears, and so on. So think creatively in sensibilizing this. And then in the beginning you will get difficult, it will be difficult meetings because you immediately have the defensive approach from software teams. Oh no, we cannot change it because it's unchangeable. This seems to be software where you cannot change anything. I don't believe it. You always can change it. They don't want to change it. And that's actually make it transparent. And that's the first step, because I'm now saying it very defensively, is start to work together. Making boards, making communities, talk about data broader than only in your data team.
Great talk. My question is related to the slide that you had about the high maturity organizations. So there you showed about how it would be better to group the data directly in domains and then have the teams kind of like own it and do it together. What are the best guidelines to actually decide on those domains, right? Because if before the domains were maybe around the systems, the technical systems, but in this case, is it more around the business functionality? Is it more about the department? So what should decide what goes into one of these domains? How do we separate them? And then how much flexibility should they have over time to change? Maybe too many questions, but
no, very good questions. And again, it's a very short answer. I would advise to go for business domains, not the system domains, but business domains. But which domains do you need? I worked for a big retailer, and they had a program of 5 years just to identify which domains they would implement, which capabilities are part of which domain. And if you already know the budget of this, it's actually a huge amount before you start thinking of systems and data products. So a generic answer to this is difficult, but it's actually more an organizational shift. You cannot just lay over a domain-oriented way of working with data products on a traditional-oriented organization. Applying this on a very small organization might also be overkill. If you know everyone, you can work faster than thinking in all these kind of things. So you need to have already a quite big organization with multiple departments, multiple sub-organizations and so on. And then it depends. Every sub-organization can have a part of a domain. A domain can come back in every sub-organization, or an organization can be a delivery of one product, one domain. So it depends on an organization. I don't have a generic answer on that, but it's difficult and a tough choice to do. So it's better first to grow without doing this complete puzzle. This is actually the additional step to fly.
Jan, thank you very much. And audience, thank you very much for these good questions, I think. So,
thank you.
Big hand of applause.